All right, in this video we're going to be graphing some absolute value equations, and we're going to be working through Algebra 2 Homework 3.3. Okay, so the first few is just, a bunch of graphs, and then there's some more interesting questions after that. Okay, so with these graphs, what I'm telling you to do is first identify the coordinates of the vertex. Okay, and for the vertex, I'm going to do this the same way every time. The x-coordinate is when we're taking the absolute value of 0. Okay, so whatever causes us to take the absolute value of 0, so I grab what's on the inside, and I set it equal to 0. Okay, so I've got the x-coordinate. And then the y-coordinate I get by plugging in 2 for x, right? So g of 2 is going to be the absolute value of 0, which is what I said was going to happen, minus 1. So y is going to equal negative 1. So 2 and negative 1 is the vertex. And then we need one other point, and I'm going to choose x equals 0, right? Yeah. So if I choose, I just confused myself because how is that going to be negative 1 as well? But if I choose x equals 0, that's going to be the absolute value of negative 2, which is 2, minus 1 is going to be 1. Okay, so g of 0 equals 1. I plot the point 0, 1. Okay, now I know that these graphs are symmetric across the vertex, so if I went over 2, I need to go over 2 in the other direction, and I will also be at y equals 1. Okay, and now I've got myself, enough points, and I guess because we are on a grid, we want this to be pretty accurate, but that's definitely good enough. Staple to contend with here. All right, and there's a graph. It's a V. All right, number 2, we're going to graph the negative of the absolute value of x plus 2. All right, well, to find the vertex, I'm going to set the inside equal to 0. So x plus 2 equals 0, and that's going to be x equaling negative 2. And then y is going to be g of negative 2, but then I'm going to be taking the negative absolute value of 0, and this is going to be 0. So I've got my thing there. Now, then, if I want to plot one other point, I would probably choose x equals 0. So g of 0 is negative absolute value of 2, so negative 2. And just going to plot, that point is here. And then if I went over 2, I need to go over 2 in that direction. I'll be down here at negative 2. And I can kind of connect my dots. But I can see that this kind of has a slope of negative 1, or 1, and then negative 1 over here. So I'm going to just try to aim. Something went wrong there. Sorry, it's close enough. It's a V shape. All right, graph g equals 1/3, or the absolute value of 1/3 of x. Okay, well, what we're going to do is we're going to say, all right, for the coordinates of the vertex, 1/3 x is equal to 0, and that would be when x is 0. Okay? And then y is going to be g of 0, which is just it's going to be 0. Okay, so I can plot my vertex here. And then I need one other point. Well, you got to be strategic about what x you're going to choose, right? You could choose x equals 1, but then you'd be plotting y equals 1/3, and that's not on the grid. So we just need to choose an x value that's divisible by 3, so I'm going to choose 3. So g of 3 is equal to the absolute value of 1, which is going to be 1. Okay, so I go over here to 3 and 1. So if I had to go to the right 3 and up 1, I'm going to go to the left 3 and up 1 because of the symmetry of these things. And then that's where I'm going to bring in the straight edge, and yeah, I think that's about right. It's looking good to me. I think that'll be good. All right, there we go. Oh, then 1/2 absolute value of x minus 4. Okay, just plot the vertex. Okay, that's where the inside of the absolute value is 0. Oh, okay, well, that's just going to be x equals 0. And then the y-coordinate is going to be, it's going to end up being negative 4. Maybe you've picked up on that it's that number that's added onto the outside. Okay, but if you haven't, you plug in x equals 0. Half of 0 is 0, minus 4 is negative 4. And so 0, negative 4 is down here. And we're going to choose some other number. I'm going to choose an even value of x so that when I divide it in half, it's still a whole number. Okay. But maybe this time I'll do g of negative 2, right? It doesn't have to be to the right of the vertex. I just happen to be doing it like that. So half of the absolute value of negative 2 would be half of 1. Wait. No. Half of 2, which is 1. 1 minus 4 is negative 3. Okay, so when x is negative 2, y is negative 3. So the symmetry over there. And now I'm going to just connect these dots. Okay, and that's good enough. Here we're going to find the coordinates of the vertex. I'm going to set the inside of the absolute value equal to 0 and solve for x. Then we are going to find the y coordinate by plugging in x equals 1. So g of 1 is going to be y. It's going to be 2 times 0 minus 6. So 1 and negative 6. Okay. I'm going to plug in x equals 0 to get my other point. G of 0 is going to be 2 times the absolute value of negative 1. So 2 times 1 minus 6, that would be negative 4. Okay, so if I'm at negative 4 when I went to the left by 1, I'll be at negative 4 when I go to the right by 1 as well. And I'll just kind of go along here. This is going to... That's a lot of graph. Okay, there we go. All right. 3 absolute value of x plus 1. Whoops, I forgot the g of x. Oh, well. It's all right. I think you'll still know how to graph that. So, let's see that the vertex is 3x equals 0. That happens to be when x is 0. And then the y coordinate is going to be 0 plus 1. Okay, x equals 0, y equals 1. And then I'm going to choose. So I need another point, and I'll say, let's just plug in 1, you know, like g of 1 is going to be, absolute value of 3 is 3, plus 1 is 4. Okay, so 1, 4. So if I go to the right by 1 and I'm at y equals 4, I should go to the left by 1 and be at y equals 4. And there we go. And there we have it. Okay. So, you know, I zoom back out, I see I've got just lots of v's, right? That's what these things look like. And I think there's like lots of things that you could, lots of conclusions you could draw about what the different numbers do to each of the aspects of the graph. And that is something that we'll talk about in greater depth later on in the course. But for now, we're just trying to produce some graphs, right? Solve some equations, produce some graphs, you know, relearn everything we learned in Algebra 1, and then add some more on. We'll talk about the more advanced stuff later. So the coordinates of the vertex on the graph of the absolute value function. Okay, well the x coordinate I'm going to get from grabbing the inside and setting it equal to 0. Okay, x minus 1 equals 0. That's telling me x needs to equal positive 1. Okay, if I want to find the y coordinate, I plug in that x value into the function. So that's f of 1 equals 3, absolute value of 1 minus 1 plus 2. And that's just going to be 2. So my coordinates are 1 and 2. Right, over here, I'm going to do the exact same thing. I'm going to find the x coordinate by taking 1/3 of x plus 2 and setting it equal to 0. Okay, that'll give me 1/3 of x equaling negative 2, and x being negative 6. Okay, the y coordinate, I'm going to plug in, pardon me, it's not f, that's g of negative 6 is going to be 5 minus the absolute value of negative 2 plus 2 is 0. And it makes sense. I should be taking the absolute value of 0 when I plug in to find the y coordinate, because that's what causes the vertex, is they taking the absolute value of 0, the sudden change in behavior. So that's going to be 5. Okay, and I feel like, oh yeah, I was going to write it as a coordinate pair. That would be negative 6 and positive 5. And there it is. It's on the screen. All right, find the x-intercepts of the graph of the absolute value function. We haven't talked about x-intercepts in a while, and so I'm glad this is on here. X-intercept, think about it. What do you know about an x-intercept? So I'm going to draw you a picture of an x-intercept. These things are V-shaped graphs, so at an x-intercept, y is going to be equal to 0. So we're just going to say y equals 0. Now in this case, f of x, it's representing y. Okay, so we're just going to plug in 0 is equal to 4 absolute value of x plus 3 minus 12. And oh, what do you know? We're back to the first lesson in this unit. We're solving an absolute value equation, right? You know I'm going to do that. So I'm going to add over here 12 equaling 4 absolute value of x plus 3s, because at this point, hopefully your instinct is to just try to solve for the absolute value, right? Isolate the absolute value, think about it, then solve more. Okay, so I'm just dividing. Okay, and if the absolute value of a number is equal to 3, then that number is either 3 or negative 3. So that means x plus 3 equals 3, or x plus 3 equals negative 3. Okay, that would be x equaling 0 right here, or I think that would be x equals negative 6. So x equals 0, or x equals negative 6. Those are going to be my x-intercepts. But it shouldn't be surprising that I could have two different x-intercepts, because, hey, look, I've got a graph with two different x-intercepts right here. And it's probably very similar to that situation. You know, the graph of 4 absolute value of x plus 3 minus 12, I have two x-intercepts. All right, but we could have no x-intercepts. And maybe, yes, here we go. Here we're going to have one that has no x-intercepts. And so I'm going to set g of x equal to 0. Okay, add 2 to both sides. Divide by negative 1. And when we see absolute value equaling a negative number, that's just, no, not going to happen, not possible. So I say there's no solution, and then there's no x-intercept. All right, now here we've got an interesting one. Find the area of the region. And we are going to have to produce a graph, I think, in order to reasonably determine what the area of this region is going to be. So I'm going to find the coordinates of the vertex, so I don't put in quadrants and realize, oh, it's actually happening down here really far or something. I don't want to draw a bad picture. So finding the vertex, first thing, x plus 2 is equal to 0. We grab the inside of the absolute value and we set it equal to 0. We've done it a bunch of times so far, and we're just going to continue to do it. And that's going to be x equals negative 2. Y equals 18 minus 9 times the absolute value of 0. Okay, the absolute value of 0 is 0. So that's going to be 18. Okay. Now I've got negative 2, 18. I know that I probably am going to need more of this, right? More positive y's and more negative x's. So I'm going to say that's negative 2. And I'm just going to say that's 18, right? Because blank canvas, this is our world, we can make it whatever we want. Okay, so we're going to need another point. But what I think the best thing for us to do here would be solve for the x-intercepts. Right? If you noticed in the past that this negative number means the v is going to open downwards, then you know that I'm going to have two x-intercepts. And I think I'm going to need those coordinates anyway in order to find the width of this triangle I think it's going to be. So I think I should probably just find the x-intercept. So that's going to be where y equals 0 at an x-intercept. And so 0 equals 18 minus 9 times the absolute value of x plus 2. Maybe, and if you're not there yet, just, subtract 18 from both sides and then divide both sides by negative 9. But maybe you can see that in order for this equation in order for this thing to come back 0 and for this equation to be true, you need this absolute value to be 2, right? Because 18 minus 18 is 0 and 18 is 9 times 2. So we're going to say 2 equals the absolute value of x plus 2. And if the absolute value of a number is 2, then that number is either 2 or negative 2. Okay, so that's going to be x equals 2 minus 2 is 0, and x equals negative 2 minus 2 more is negative 4. All right, so that'll be nice because x equals 0 will be an x-intercept, so that means I'm going through that point, and I should probably draw this one first. And let's say that's about here. But again, this is just a sketch that is going to help us determine the area of this region. Okay, the region that I want the area of is going to be that triangle, right? Okay, so if I went from -2 over to the right by 2 to get to x equals 0, I need to go to the left by 2 also to get to x equals -4. But what I'm going to just say is that we've got ourselves a triangle here that's got a width of 4, right? 2 that way, 2 that way. And a height of 18, because it goes from the x-axis up to y equals 18. So we know that area is equal to 1/2 times the base times the height. And 2 times 18, that's 36. Okay. 12 and 5. Okay, I know what's coming here. Pythagorean triple. So find the perimeter of the region enclosed by the graph of y equals 12 minus the absolute value of 12/5 x and the x-axis. Okay, so I'm going to find the coordinates of the vertex. Okay, 12/5 x equals 0. Grab the inside, set it equal to 0. Oh, that's only going to happen when x is 0. Y is going to equal 12. If I plug in x equals 0, y will be 12. And so I think I'm just going to need, I bet it's going to kind of come back down, minus 12/5 of x. So I might just find the x-intercepts again. That seems like a good way to go. It worked for me last time. Might as well try it again. So x-intercept, that's where y equals 0. So 0 equals 12 minus 12/5 of x. Then I'm going to subtract 12 from both sides. I think, what do I need to multiply this number by to get -12? Oh, I would need to multiply by 5, so the 5s would cancel, 5 over 1. Or you could multiply and divide by 12 if you want, but I don't think that's the way to go. And that's going to be x equals... What just happened here? Oh, I just completely neglected to copy these absolute value bars. Okay, so I'm going to divide both sides by -1, and okay, if 12 is equal to the absolute value of 12/5 of x, I only need 1 point, and you can see x equals 5 is going to work, so x equals -5 works as well. But if we're solving this equation, the way that I showed you how a couple times ago, we're going to say if the absolute value of something is 12, then it is either equal to 12 or it's equal to -12. And then this would give me x equals 5 or x equals -5. All right, so then that's going to go down over here. And really, because I haven't marked anything on the x-axis, I can just make this however I want. Okay, but that's going to be 5, and that's going to be -5. Okay. And then what I'm going to point out to you is that this interior triangle here that I'm kind of showing in blue, you can barely even see that it's blue, but okay, this interior right triangle, this is a right triangle that has legs 5 and 12, which means that the hypotenuse is 13. That's a triple that you want to know, especially if you're the type of student that's about to take the PSAT and SAT and ACT. Those 5, 12, 13s, they come up all the time. So if I've got my whole triangle, the region enclosed by the graph and the x-axis, that's going to have a width of 10 down here, and each of these legs is 13. So perimeter is going to be equal to 10 and 13 is going to be 36. Oh, so same as before. All right. Now we're going to write an equation for the graph shown below. Okay. This is a little tricky for the amount of knowledge that you have right now, but I'm thinking that we can really just go off of the vertex and off of the slopes that we're seeing. And I think that should be enough to make us able to write an equation. Now, in general, there are going to be a lot of different equations that might look a little different that could all represent these same graphs. Okay? So what I'm going to do is I'm going to say that eventually I'm going for the absolute value of x minus the x-coordinate of the vertex, because I know that if I plug in the x-coordinate of the vertex, I need to be taking the absolute value of 0, multiplied by some kind of slope number on the outside, right? Because hopefully you've noticed that the number that gets multiplied by x on the outside or on the inside kind of gives us the slopes of these things. And, with it being negative if it opens down and positive if it opens up. And then hopefully you've noticed the y coordinate of the vertex is kind of like added on the outside. I'll tell you, I'm kind of, well, you don't need to worry about this question for the quiz, is what I'm going to say. This is a little beyond where we are right now. But it's something that we'll come back to later on in the course, and we will be able to do this problem, pretty confidently. Okay, so what I'm thinking is, and I was going to label over here, vertex is going to be x0, y0, slopes like plus or minus m. Okay, and then we'll just have to make sure that we're considerate of if it's opening up or down. All right, so y is going to equal some number of the absolute values of x minus, okay, the vertex is at -3, -1. So I'm going to do x minus -3 because when I plug in -3, I need to take the absolute value of 0. Okay? And then when I plug in x equals -3, y needs to equal -1. And I look at the slopes and I see I kind of went over 2, down 1. And then, over 2, up 1. So the slopes are like a half and -1/2. So, you might not think a half. But if you were to graph this, you would find that that opened up, okay, like a regular looking V. So I need to make that negative so it opens down. Okay? And then for this one, I'm going to kind of start with the same way. Start with the same kind of skeleton. Y equals some number of an absolute value of, okay, the coordinates of the vertex are 1 and 3. So it's going to be x minus 3, okay, because I need to be taking the absolute value of 0 at my vertex. That is not what it, right? I plug in x equals 1, so that would be x minus 1. All right, some number of x minus 1s, the slope number of x minus 1, so the slope is 2 and -2. Okay, but it's opening up, so I'm going to use +2 as my kind of slope multiplier. And then to get, a y coordinate of 3 at the vertex, when I plug in x equals 1, I'm going to need to add 3 after that. And that's going to be, these are going to be two decent equations for these graphs, right? They're not unique, though. There are others that could describe that might look a little bit different, but would produce the same image. All right, write an inequality for the graph shown below. Well, this is going to be tough because I can't even see another grid intersection point. I got to assume this is a slope of 1/3. Okay? So I'm thinking 1/3 of the absolute value of x. And since it goes through the origin, the vertex is at the origin, I don't need to add anything to x or add anything on the outside. So if this was just the line, it would be y equals. But since it's below, it's where y is negative and more negative than this line, I'm going to say less than or potentially equal to because it's a solid line. This one over here is a dotted line. So, and this is where y is above this V shape. So it's going to be y is greater than. Okay. It's going to be some number of the absolute value of, I think, x minus 3. Okay, because the x coordinate of the vertex is 3. The y coordinate is 0, so I'm not going to add anything over here. And the slopes are 1 and -1, and so I could just put a 1 there, or I could just not. And but since it opens up, it's going to be positive absolute value of x minus 3. And that's a good one too. Okay. Now we're going to determine which quadrant contains the vertex of f. All right. I'm just going to grind through these. I'm going to actually compute the coordinates of the vertex and then do it that way. If you want to go on a positive negative level, if you've kind of figured some stuff out, you do it that way, right? This is not the type of thing where I would, if I was grading this, I would be checking your work, right? Because I think that some people are going to be able to just do these mentally. Okay, so the x coordinate, that's going to be where x plus 5 equals 0. That's x equaling -5. Y, f of -5 equals the absolute value of 0 plus 2. So y equals 2. If I have -5 and 2, x is negative, y is positive, that's quadrant 2. Okay. Again, okay, for x, I took the same 1, so I'm going to get x equals -5 again. I had the same thing on the inside of the absolute value, so I don't need to do that again, right? I already did that. And then y is going to be, well, the only difference is 2 to negative 2, so that would be y equals negative 2. So if x is negative and y is negative, well, that's going to give me quadrant 3. Okay. X minus 5, absolute valued minus 2. Okay, that's a little different. So to compute x, I'd say, all right, x minus 5 equals 0, and that would be x equals 5. And then to compute the y coordinate, I'm going to plug in f of 5, which is just I plug in 5 wherever I see x, so absolute value of 0 minus 2, that's negative 2. Okay, so if I've got positive 5 and negative 2, then where x is positive and y is negative, that's quadrant 4. Okay, now it stands to reason, probably, that if I've given you 4 and, I've got 2, 3, and 4, that this last one would be 1. And so I'm, maybe you're expecting to see that, but not going entirely off that. We need some algebraic evidence as well. Okay, so to get the x coordinate, we'd say x minus 5 equals 0. Oh yeah, we just did that. That's x equals 5. That wasn't so hard. And then to get y, we'll take f of 5, which will be the absolute value of 0 plus 2, which is going to be 2. Okay, so 5 and 2. X is positive, y is positive, that's quadrant 1. Just 2 more. Solve by graphing. These are some good problems. Okay, I'm not a huge fan of the solve by graphing system of linear equations where it's just 2 lines, because that's like, But solving this one by graphing, well, I'm going to show you that we've actually solved this one algebraically before, and I'll show you what's going on here. So y equals 2x, that's going to be our first. Okay, so let's see, 6 and 12, that's a point. And then I'm going to do negative 6 and negative 12. That's another point, so I can get myself like a really good line. Good stuff to aim at. See, I messed it up. Okay. But I don't think that's where the intersection is going to happen down there. And you couldn't even see that on screen. So I'm not going to show you. That's 2x. Okay, then I'll graph the absolute value of 4x minus 12 in red. Okay, so I need to find the x coordinate of the vertex, and that would be where 4x minus 12 equals 0. And then I would add 12 to both sides. Divide by 4 and get x equals 3. And then the y coordinate of the vertex, if I was graphing the absolute value of 4x minus 12, well, that would be just, if I plugged in 3, I'd get the absolute value of 0. So it's going to be here. And then, another way to graph this besides, just picking an x value and plotting a point and checking the symmetry is looking at the slope number, right? This is 4. So I'm going to go over 1 up 4 this way. I'm going to go over 1 up 4 that way because it's got to be a v, and since it's the positive absolute value, it's going to open upwards. So it's got a slope of 4. Oh, nice. I actually found one up here. I kind of forgot that was going to happen. Okay, 1, 2, 3, and some. Okay, so I've got 2 intersection points. Okay. So these are the corresponding to the solutions. So this is where x is 6 and y is 12. And you can check to see, does x equal 6 solve this equation? Does 24 minus 12 equal 12? Yes. Or the absolute value of 24 minus 12, does that equal 12? Yes, definitely. Okay. And then this other one is 2 and 4. Okay. So my solutions to this equation are x equals 2 and x equals 6. Now, I'm going to really quickly run through this because I got a little bit of time, but I'm going to show you how if we had solved this one algebraically using techniques from the first lesson, that we'd get the same thing. So if the absolute value of a number is 2x, then that number is either equal to 2x or it's equal to the negative of 2x. Okay. And then I'm just going to solve both of these equations. I'm going to subtract 2x. Okay, I'm going to say, okay, I would need this to be 12 because 12 minus 12 is 0, and then 2x needs to be 12, and then that would be x equals 6. Okay, over here I'm going to add 2x to both sides. Divide both sides by 6, and x equals 2. X equals 2, x equals 6. Same. So it looks like we've got, one more of these solve the equation by graphing, and maybe this one will have like an extraneous solution, man, I'm hoping. And, since I just did that other one algebraically, I'm going to do this one algebraically as well. So if the absolute value of a number is equal to negative x plus 3, then either the number is negative x plus 3, or maybe it's the negative of that number. So that would be 2x plus 6 is equal to the negative of x plus 3, which would be positive x minus 3. I think I said the negative of x plus 3, but I meant the negative of negative x plus 3. So I'm going to solve these equations separately. I'll have 3x, and then I'm going to subtract 6. No, maybe I'll just do that in one step. 3x plus 6 equals 3. 3x equals 3 minus 6 is negative 3. X equals negative 1. Or maybe I can go over here and I can subtract an x and subtract a 6. I did it 2 steps in one. I try not to do that on these videos, but I've got x equaling negative 9. I'm not going to check these, but I can see that negative 9 is going to be an extraneous solution because, because it's negative x plus 3. Maybe neither of them are extraneous. Okay, maybe you're interested in the extraneous solution, what that looks like on the graph, and you can talk to me about that tomorrow or whenever you see me next. All right. So negative 1 and negative 9 are my solutions, but I can't just start by graphing the solutions. I got to graph y equals negative x plus 3. Okay, I think that's right, and it's not. I've gone too far. Okay, and then the y equals the absolute value of 2x plus 6. I forgot to kind of label these, but okay. So if we graph y equals the absolute value of 2x plus 6, we can figure out the x coordinate of the vertex by saying 2x plus 6 is equal to 0. And then, the y coordinate of the vertex would be when I plug in x equals negative 3, I get y equals 0. So, got negative 3 here. And then, the slope number is 2, so I need to go over 1 up 2. Okay, I found one solution, over 1 up 2, over another one up another 2. Keep going. Each time over 1 up 2, keep going. There we go. Okay, we found ourselves our solutions. And I'm just going to kind of graph until I see what I need to see, which is these lines running into each other. And then I see, without even going in and checking, I can just see that neither of these are extraneous solutions because I've got two intersections, right? X equals negative 1 and x equals 9. Is that what I'm seeing? X equals negative 1. No, not 9. Negative 9. But sure enough, there we go. And so that's what we're doing graphically when we're solving these equations. Okay? I actually find that solving the equations is much less error-prone than this. This is where we make a lot of mistakes. Okay, that's all I got for you for this video. Thanks for watching.